Scott Coffin, was born in Cheyenne, Wyoming, a Central High School graduate, and he completed his BS in chemistry from the University of Wyoming. In 2018, Scott obtained his PhD in environmental toxicology at the University of California, Riverside, focusing on plastic as a vector for chemicals to marine to estuarine animals. Scott currently works as a research scientist at California State Water Resources Control Board, in which he serves as the technical lead on the state's efforts regarding microplastics in drinking water. And he'll be talking to us about microplastics. So plastic pollution has been studied since the 1960s, with most of the research focusing on marine and freshwater environments. Recently, impacts of microplastics have been documented in the terrestrial biosphere, including in humans, ecosystems, and agriculture. Awareness of potential direct harm to humans through food, water, and air has prompted government agencies to act. Notably, the California Legislature passed the Senate Bill 1422 in 2018, which requires the State Water Resources Control Board to define and monitor microplastics in drinking water, as well as develop standardized methods to assess human health effects. Additionally, microplastics may cause indirect impacts to humans through decreased food security as a result of plant and animal toxicities, increased antibiotic resistance, and impaired ecosystems. Although indirect impacts are poorly understood, some agencies are taking precautionary measures to mitigate impacts through reduction of plastic production and enhanced waste management practices. So thank you, Scott, for doing this for us.
Awesome. Thank you for the introduction, Kelly, and for inviting me to speak to you all today. So I'm going to go ahead and start screen sharing my presentation. Alrighty. So everyone should be able to see my screen share. Alrighty. So yeah, thanks for the introduction, Kelly. I guess a little bit of background about me. I'm, as Kelly mentioned, a Wyoming native. I grew up in Cheyenne and recognize a lot of you from growing up. I obtained my Bachelor's of Science in Chemistry from the University of Wyoming and spent most of my time rock climbing, even though I told my mom I was studying. Then after graduating, I went to Belize and Costa Rica to guide international outdoor trips. And it was on these trips that I became aware of plastic pollution. Not having been to coastal environments much throughout my life, I hadn't had the opportunity to really see firsthand the impacts of plastic in these marine habitats. And so finding trash in otherwise pristine, uninhabited places really left an impact on me. And when I looked closer into the sand, I found that it was not just these large pieces of plastic, but in this case, I actually found a lot of microbeads and pre-production pellets, as well as other microplastic fragments. And so this got me thinking, this is 2013, 2014, when the whole plastic pollution thing was really just starting to enter the news cycle. And so when I got back from abroad, I started doing some research, and I found that this plastic problem isn't just in the coast. It's not just a problem in coastal areas. They actually have found microplastics in much more locations, including the top of mountains and uninhabited places, Arctic glaciers, the deepest part of the ocean. It's ubiquitous, as by now everyone in this room is probably aware of. So I guess I want to see how test everyone's plastic knowledge. So I'm going to ask a question to everyone. You should see a poll come up. And when you get a chance, you can select your answer. So only one of the following has not had microplastics found in it yet. And I may have given you a hint. It may have been a bad hint, or maybe trying to trick you. We'll see. Awesome, thanks for answering that. So it looks like I tricked everyone. actually, we have not discovered microplastics in human tissue. Some of you may have actually seen a news report that came out last week about a study that found microplastics in human tissue. That was actually a misrepresentation of the study, and the Guardian that broke the story and misrepresented it has since updated their story. And I guess I just want to point this out as something that is critical in our field, which is a lot of hype and misrepresentation in the science. And it's something that we're dealing with on a daily basis. When this, we actually didn't find microplastics in human tissue, but we developed a method to. So that's what that study is, if you're aware of it. But I'm sure we'll find microplastics in human tissue soon enough. So stay tuned. So after completing my PhD at UC Riverside in environmental toxicology, working with Professor Daniel Schlenk, shown here, I got a position at the California Environmental Protection Agency, or Cal EPA, specifically in the California water boards at the state level, to regulate drinking water contaminants, as well as perform research and inform the legislators and the public, including you all, about different environmental and public health topics, and specifically to focus on microplastics in drinking water. So let's talk about plastic. We all know that it's abundant. And if you look back to the 50s, you can see how it came to be so abundant in our lives. Life magazine had a classic 1955 cover that showed that plastic was a solution for household chores. And so this single-use plastic, it's no wonder that we see it everywhere, where we're really dependent on it. And the problem, of course, is that these macroplastic particles, something like a single-use bottle, doesn't really go away, but it does degrade into smaller pieces that just get smaller and smaller and can interact with animals and humans and plants that interact with these really small particles. And this problem is not going to go away on its own. By all estimates, we're set to double the amount of trash that we put into the ocean by 2040 from now. And there's a lot of different mitigation things that we can do. If we just focus on recycling, that's a really small percentage that we can reduce. If we focus on big things, reduction, substitution, that'll take out a good chunk. And then, of course, disposing and managing the waste are really huge, could have really huge effects on the amount that we put into the environment. So a critical question that has been asked recently is, are humans at risk from microplastics? And in order to answer this question, it's important to consider what risk actually means. To toxicologists, risk is a factor of hazard, the potential to cause harm, in this case, a diamondback rattlesnake, and the exposure. If you're not exposed to the snake, there is no risk. But if you're exposed, like Steve Irwin is, you may be at risk. So the consensus on risk of microplastics for humans. Unfortunately, the consensus is that we just don't know. There's no evidence of safety, but there's also really no evidence of harm at the levels that we're being exposed to today. And that being said, I'm going to go into research that has been conducted mostly after this report came out. So this is really, really recent. A lot of this has been published within the past 9 months, some of it within the past week or yesterday. So exposure does not equal risk. This is a common misconception that I see a lot in the media, and actually 93% of media articles on microplastics imply that exposure is equivalent to risk, using terms such as hazard, threat, toxic, bad. And very few of these articles actually discuss what toxicologists consider hazards. So how the plastic actually is toxic and whether or not it is toxic, because at this point, we really don't know much about it. And so this is I just wanted to point this out as, sort of something that I see quite often and a bit of a myth that can be busted. So what do we know about the actual exposures to microplastics for humans? We can look towards the medical literature and find that there are examples of occupational exposures in which people have been exposed to extremely high amounts of microplastics over chronic periods of time. Workers in Rhode Island in a nylon flock facility were exposed through inhalation, and they were found to have 3-fold higher increases in lung cancer compared to their their cohort in Rhode Island that don't work in the plant. And doing toxicity studies in mice and in cells, the researchers found that small microfibers found in lungs were the ones that were responsible for these toxicities. And they found that overall, the main mode of action is inflammation. You could think of this similar to being exposed to asbestos. These small microfibers interact at a physical particle level to disrupt the immune system, as well as as other processes in the body. And so something to understand about these particles is that these fibers that the workers were exposed to were very small. And this is quite relevant when it comes to being exposed to a particle of any type. Particles below 10 microns can pass through the gut and be taken up into the epithelium. When they get below about 1 micron, they can be taken up into cells. And these are really small numbers, really small sizes. 10 microns is approximately the size of a red blood cell. 1 micron is the size of smaller cells. And then a virus is the size of about 100 nanometers. So just to give you an example, so you can't see these particles. The 10 micron and below, you won't be able to see them. So in addition to the physical component, the physical toxicity of these particles, there's also a chemical component for the hazard of being exposed to microplastics. And the thing with plastic is that it just sucks up any other chemicals that it interacts with in the environment. Researchers have been using this for decades as a way of passive sampling for chemicals. So PCBs, PAHs, lead, nickel, any of the contaminants that we've been putting out into the environment for decades, it's going to find and absorb to. Additionally, there's chemicals that are intentionally added to plastic that give it favorable properties. A lot of us have heard of BPA. There's also phthalates, styrenes, and PBDEs. PBDEs are flame retardants. And the trouble with some of these ingredients is that some of them are endocrine disruptors. Endocrine disruptors have been in the media a lot recently as, and you can think of 17-beta estradiol is a classic example of an endocrine disruptor. This is birth control. This is an endogenous hormone that your body produces, and you can take this pharmaceutically. It has effects at extremely low doses, and it's quite similar to some common plastic additives. As you can see here in red, the chemical moiety is quite similar to that in 17-beta estradiol or estrogen. And the problem with endocrine disruptors is that they're really difficult to predict how they behave toxicologically. On the left here, you can see what's known as a typical dose response curve, where you have a higher dose, you have a higher response. Most drugs work this way. For endocrine disruptors, it's not so clear. You can have an effect at a very low dose, and then you can have a much lower effect at a higher dose. And so this makes predicting the effects of these endocrine disruptors extremely challenging. And so very small quantities of some of these chemicals can be very hazardous. Additionally, we know that endocrine disruptors may be some of the most impactful chemicals to our society as a whole. Looking at the IQ loss of Americans between 2001 and 2016, the majority of IQ loss can be attributed to PBDE, which is a flame retardant. And this is far more than lead, mercury, or pesticides. And in fact, between 750,000 and 175,000 intellectual disabilities. So people that have been so severely impacted by these compounds that they actually have a clinical diagnosis of an intellectual disability have occurred in just in this time range in the United States alone. So this has dramatic society level effects that can impact the economy in a quantifiable manner. So time for another quiz. Approximately how many unique synthetic chemicals exist? I want to hear what ranges people think. And at this point, if anyone has a burning question, feel free to unmute yourself and ask me.
I would like, while you're looking at that, this is Kathleen. You know, there's such a high increase in autism that's been diagnosed of individuals on the autism spectrum. And I've often thought it has to be related to some kind of chemical or something that people are being exposed to. Is that part of the study that you were talking about when you're talking about the interruption of the intellectual and whatever that was impacting the brain? So is that part of that, Scott?
I'm not aware of any direct relation with endocrine disruptors and autism. My reading of the literature on autism is that it's really difficult to pin down factors. They know for certain that vaccines are not related to autism, but the actual causes are still quite unknown. But your intuition is right that it's probably some chemicals that we're being exposed to. So let's look at the results. Wow, most of you said hundreds of thousands. That is a lot of chemicals. A couple people guessed the correct answer, which is hundreds of millions. So it's an unbelievable quantity, but let's look at how we got here. Go back 50 years, there were extremely few chemicals. And by 1975, we invented 3 million. This is a huge accomplishment. Fast forward to 2015, we have over 100 million unique organic and inorganic substances that have been registered. And these are just the ones that have been registered. Other chemicals likely exist. And the problem with making all of these different chemicals is that a lot of them end up in our consumer products. And there's no consumer product that has more added ingredients than plastic. Over 85% of plastic ingredients are unknown or confidential. And this is due to regulations in the United States under the Toxic Substances Control Act, or TSCA, that prevent or that allow manufacturers to not disclose what types of chemicals are in their products. And for the most part, food contact materials, things that we eat out of, are not containing the most harmful chemicals, most cases. But in the case of microplastic exposure, you could be exposed to chemicals that were never intended to be exposed to humans. Things found in cars and tires, industrial things. So this is going to be a huge uncertainty forever, honestly, with plastic, because I don't see the regulations changing on the confidential business information in the United States anytime soon. Most other countries don't allow this, by the way. So I just talked about the hazards. That's one side of the coin for risk. The other side is exposure. And what we know, which is very little, is that air is most likely the greatest exposure route, microplastics. But this is based on very few studies. We've looked in seafood, bottled water, sugar, tap water, alcohol, salt, and honey. What you see missing from this list? Food. We don't really know what's in food. And so air, this is sort of surprising. A study published just a few months ago actually looked at national parks, and they actually found that Rocky Mountain National Park had the highest abundance of microplastics in the air of any of the national parks that they tested in the western part of the United States. And this is surprising because Rocky Mountain National Park and a lot of these parks are not urban environments. You wouldn't expect a lot of plastic or human-related substances to be found in these rather remote areas. And they found that in some cases, up to 6% of the dust was actually just made of plastic. And when you look at indoor air, it gets harder, it gets worse. Unfortunately, indoor air can be up to 15 times more polluted than outdoor air for microplastics. And between 1.5 and 13% of dust that you're breathing in on a daily basis indoors is actually microplastic. This is really recent findings. And most of this is really fibers from our clothes, but also fragments from the things that we use on a daily basis that just break off. Much like any other air pollutant, you really only got to worry about the small stuff. So when you look at your air quality indicator for right now for Cheyenne, look at it for smoke. There's gonna be a lot of smoke particulates. It'll give you two metrics. It'll say PM10, PM2.5. And that means particulate matter between below 10 microns and particulate matter between below 2.5 microns. And when you get below 2.5, as I mentioned earlier, the particles can reach deeper in the body and they get much more toxic. So all these particles floating around, no wonder that some of it is going to end up in surface water. In addition to air, wastewater emissions, stormwater, direct emissions, just people tossing things that end up into streams. These are different ways that microplastics can enter our surface waters, which are sometimes used for drinking water. And it's no wonder then that in 2017, we found microplastics in tap water. Since then, there have been a number of studies looking at microplastics in both tap and bottled water. And overall, they found more microplastics in bottled water on the order of 10 to 1,000 times more. And this in part may be due to some sampling bias with different methodologies, but we think that it's mostly due to the bottle itself. So looking at a typical PET plastic water bottle that you buy, when you unscrew the lid, small fragments break off on the order of about 14 to 2,400. And this isn't just a plastic water bottle, it's anytime you interact with any plastic. So opening a snack bag releases 14,000 to 75,000 microplastic particles. Whew. That sounds like an enormous number, but I want to remind everyone that that's exposure, and we don't know how much causes risk. So unfortunately, these large numbers are a little bit meaningless until we have a better handle on how much is actually risky. So the good news, most water treatment plants effectively remove microplastics. Looking at drinking water treatment plants, we see 87 to 99.9% removal. This is great news. Unfortunately, it's mostly the small particles that we really need to worry about, and these are not always removed. But for the majority of the big particles, they are. Wastewater, same story. We see between 88 and 99% removal for most wastewater treatment plants. And if you look at a typical wastewater treatment plant, almost all of them remove the sludge, the primary settling. And this is where about 88% of the microplastics are going to be taken out. Some of it, about 1%, may be discharged into the ocean or other surface waters. And so where does that sludge go? I want to know. I want to know where people think the sludge goes. So I'm going to launch a poll. And again, if anyone has a burning question, feel free to unmute yourself and ask.
So Scott, this is Teresa. Hi.
Hi.
I'm curious, the plastic bottle, I'm assuming that is not the same with glass water bottles. Is that true? You mentioned the...
as far as the bottled water, yeah. So that's plastic water bottles.
Yeah.
Yeah. So a glass bottle, the ones that they've tested almost always have significantly less than the plastic water bottles.
And just while Kathleen asked about autism, is there a connection with IPF, idiopathic pulmonary fibrosis?
I don't know the answer to that. I'm sorry.
All right. My father is dying of that.
Oh, I'm really sorry to hear that.
Yeah, but they think it's environmental, but they haven't proven it, or I haven't read.
Yeah, I'm not an expert on fibrosis and pulmonary fibrosis. Not a medical doctor, just an environmental toxicologist. Sorry. Alrighty, so I'm going to end the poll. Wow, everyone did really great. The answer is actually all of these places, but where does most of the sludge go? In the Western world, we send most of it to our agricultural fields because it's rich in carbon. It's a great source of nutrient for plants, and so it's reusing that has been greatly advantageous for farmers and as a way of reducing greenhouse gas emissions and general pollution, by sending it to a landfill or incinerator or oceans and rivers, which they sometimes do in some places still. So now that we know that the sludge is filled with microplastics, now let's look where it goes. So some of you know it goes to agricultural fields. This is used quite common at ag fields in Colorado. I wasn't able to find any information about Wyoming specifically. I think that they do allow the application of what's known as biosolids, which is a fraction of the sludge. But it's certainly encouraged in Colorado and in most places. And what we know, this is very recent, is that microplastics concentrate in these agricultural soils. Makes sense. 88% of it goes into the biosolids, and they're being continuously applied to agricultural lands. They tend to float to the top because they have a lower density than other particles in the soil. And very recently, we found that plants can actually uptake and accumulate these nanoplastic particles. Certain plants will take them into their root tips and translocate them up through the rest of the plant. And very recently, there's been some toxicity studies done on this. They found that the uptake of nanoplastics, so plastic particles that are in the nanometer range, cause growth inhibition in a dose-dependent manner. And so over time, eventually, agricultural soils may become toxic with the addition of these biosolids. So this is really something to keep in mind for agricultural practices, as this may dramatically shift how we use our biosolids and what we do with our sludge. So it's sensible to think that if a plant can take up microplastic, in this case a nanoplastic, you would find it in the fruit and vegetables. And a study investigated this earlier this year. They used a technique known as scanning electron microscopy to look for these nanoplastic particles in various fruits and veggies. And they came up with some dramatically high numbers on the order of about 300,000 or 300,000 particles in an apple, single apple. And that sounds like a crazy amount. Unfortunately, this study is largely recognized as being essentially useless. The methods that they use are not validated, and they don't properly describe how they use them. And honestly, it shouldn't have been published. So if you've seen this type of article being spread around, because it's quite a sensationalist, and it really is the only finding of plastic in fruit and veggies, just know that it's 100% not accepted by the scientific community. So unfortunately, the scientific field of microplastics is really nascent, and we have a lot of learning and growing to do. So let's get back to plastic and tap water. In 2017, I mentioned earlier, in 2017, a study found microplastics in tap water. This was the first study of its kind, and oddly enough, it actually never was peer-reviewed. It broke through the media first, and they looked at microplastic in the tap of many different countries, and they found that overall, most samples contained microplastics. This was really concerning to just about everyone. And this report actually turned into policy remarkably fast. Looking at Google Trends, here we can see a graph of different search terms. This is an analysis I did earlier this year looking at microplastics in water, microplastics in drinking water, and seeing if there's any correlation between this media report and the public's interest. And of course, there was a huge spike. This caused legislators to take notice as their constituents were concerned. And within months, California passed Senate Bill 1422, which I'll talk about in a bit, addressing microplastics in drinking water. Interestingly, the first ever peer-reviewed report of microplastics in drinking water was published after the legislature decided to take action. So this really highlights the power of you, the power of the public, the power of people taking notice and taking concern and informing their policymakers, their decision makers of their concerns. So California Senate Bill 1422 requires the State Water Resources Control Board to take action on microplastics in drinking water. And the first step is just defining what microplastics means. There's a lot of different definitions out there. And then we have to figure out how to measure it, monitor it for 4 years in California, come up with some sort of health-based guidance level to aid consumers to know what microplastics in their drinking water actually means, and then accredit laboratories so we can compare the data. So this bill was passed in tandem with Bill 1263, which requires the Ocean Protection Council, in collaboration with the State Water Board, to initiate a statewide microplastic strategy, which involves developing a risk assessment framework, standardized methods, figuring out how much microplastics are out there in the ocean, figure out where they're coming from, and also recommend source reduction strategies. So talking about the definition, it's first important to realize that microplastics is an extremely diverse contaminant suite. And I'm going to quiz everyone on all of the words that are on this figure at the end of this talk. So make sure you memorize all of these. Totally joking. Please don't do that. This is really just to show you that this is an extremely diverse contaminant suite. We've got every polymer in the world, additives, like I mentioned, could be in the hundreds of millions. We've got sizes, shapes, colors, everything you can think of. So how do you come up with a definition that can encompass all of those different factors? In June of this year, we adopted the first regulatory definition of microplastics for the purposes of drinking water in the world. And so we based this definition off of the European Chemical Agency's definition, which they had been iterating for about a year, but we modified it in several distinct ways. So I actually wrote this definition and the staff report for it. And the biggest things about this is that it goes from 1 nanometer all the way up to 5,000 micrometers or 5 millimeters. And this is a huge range of sizes. Everything from something that you can see, like your thumb, to the smallest nanoparticle possible. And the polymers that we have decided to exclude are those that are derived in nature, that have not been chemically modified, other than by hydrolysis. So that means something like cellulose, chitin, a naturally occurring thing, because polymers are not just, not just synthetic. A polymer can be DNA or your hair. And so we didn't want to include those. Other than that, it's an extremely inclusive definition. Our definition is distinct in a fundamental way from the European Chemicals Agency. The Europeans are excluding biodegradable polymers from their definition. And this really comes down to the different purposes of these definitions. Our definition is solely to protect human health in drinking water. So we don't care if it's biodegradable or not. If it's toxic, we want to know about it. The Europeans, their definition is for a restriction proposal. So what can you intentionally add into the environment? And if the particle biodegrades, then it probably won't be around for a while, and it may not interact with humans. So that's the reason that they are excluding biodegradable polymers. I mentioned that biodegradable polymers may be toxic. In fact, the most evidence that we have demonstrates that they may actually be more toxic, unfortunately, than their non-biodegradable counterparts. at least in the form of transferring chemical contaminants to humans. They do so in a much more rapid way because the particles actually break down when you eat them. So the polymers that we include in our definition is everything from 1 to 7 recycling codes, as well as things that you might not actually think of as plastic. And this includes things like synthetic rubber, tires that haven't been, have classically been excluded from microplastics definitions, synthetic fibers from clothes, silicones, like this bag here, bio-based biodegradable polymers, and cellulose acetate, which is the tobacco industry says is biodegradable and is non-plastic. So this includes things like silicone that I mentioned earlier that actually sometimes claim to be 100% plastic-free. So they may need to change their labels now that our regulatory definition labels it as plastic. And so now that we've defined the problem, we can begin to address the problem. And right now we are conducting a study to develop a method and standardize the method between approximately 35 laboratories in 7 different countries. They're using a variety of techniques to standardize microplastics analysis in tap water, ocean water, fish tissue, and sediment. And we'll be discussing the results from this work later this year. The last thing that we really need to consider is the health effects. And I gave you a teaser of what we know, but it goes a lot deeper. And there's been quite a few studies that have been published in just the past 6 months alone on this. And so to give the best answer that we can to the public, we'll be organizing a health effects workshop with the leading experts in the world over the course of several weeks. It'll happen over Zoom, and we'll be disseminating the results from this working group meeting in the spring of next year. We'll also be tackling ecosystem health while we're at it. So with that, I'd like to thank you all for your attention. If you would like to tweet at me, if you're into Twitter, here's my handle. You can also just send me a good old-fashioned email. I list my professional email address here. So please, I want to hear from you if you have any questions, if you want to collaborate or pick my brain anytime, please feel free to. So with that, I can take any questions from anyone.
So Scott, thank you. And we do have a couple of questions in the chat room.
All right. Let me go back. I see. What are the public pathways for exposure to PBDEs? That's a great question. Thanks, Shane. So the majority of PBDEs that we're exposed to is from our furniture. California passed a law in the 1990s that requires manufacturers to make sure that their products meet flame standards, flammability standards. Fires are a big deal in California, and so they wanted to make sure that homes were a little bit less flammable. And one way to satisfy this criteria is to add flame retardants, just spray it on. And so these flame retardants, they fall off as dust. And a lot of the particles that we are ingesting or inhaling from our home are just actual flame retardant particles that have, they've made like nanoparticles. And so that is one way. Another way is actually through microplastic exposure. They're finding that a lot of these microplastic particles are just loaded with PBDEs. So this, that may actually be the biggest exposure pathway. And this is an evolving matter. Since it's a California regulation, but manufacturers didn't want to make specific furniture for California. They wanted to make it for everybody. And so our progressive policy actually ended up affecting everyone in the United States that buys furniture. So recognizing the health effects of PBDEs added to furniture, we actually passed a law in 2015 that allows furniture makers to not add these chemicals. And if you flip upside down whatever you're sitting on right now, your couch, your chair, if it's made in the past 5 years or so, it will have a label and it will tell you whether or not it has flame retardants.
Our next question comes from April, and she's going to ask the question, I believe, right, April?
Yeah, sorry, I just didn't know how to type it out.
You're
and
good.
word it the right way. Well, I'm up in Texas, and recently we had a huge fire at Polymerica plastic production plant, and it's about 15 miles away from my house, you know, and you could see the smoke. It actually nobody was hurt, thankfully, but it was burning like their storage supply of all their plastics. So my question is, you know, even though it's 15 miles away and like the smoke wasn't directly coming over my house, you know, I could see it in the distance. Does that air quality affect, like, how far does that air quality get affected from something like that?
That's a good question. Yeah, that's a really good question. So for the volatile organic chemicals, which are going to be the dioxins, which are going to be burning off of those plastics, those are going to be concentrated near the plant. 15 miles may be far enough. It depends on the way the wind is blowing, honestly. But particles can transfer thousands of miles. When there's a dust storm in Africa, sometimes you can see the particles end up in Puerto Rico or North America. So there's really like long range transport of these compounds, or the particles is common. As far as the chemicals themselves, yeah, it's much closer range that you need to worry about. But that's really, I'm really sorry to hear that you live close to that plant. Yeah, I mean, you bring up a huge point about the inland impacts of plastic. Texas has so many plastic manufacturers that violate US EPA air quality emission standards and are constantly discharging toxic air.
Our next question comes from Kathleen Peterson. She's asking, is it safe to eat fish?
It depends. It depends on where you're getting your fish. In California, we have fish health advisories that are put out almost weekly for different fish from different areas. But as far as microplastics contamination, the contamination is quite low. You're more likely to have you're more likely to have microplastics fall onto your plate in higher quantities while you're eating the fish than the most contaminated mussels that exist in the world with microplastics. So I wouldn't worry about microplastics in seafood, but I would worry about mercury, which shows up in tuna. So I would say just check the label, figure out where it's coming from if you're worried about it.
And this is my opportunity to push for the sustainable fishing. Please check out Monterey Bay Seafood Watch. They have an app and they'll tell you what type of fish to eat and what type to not eat because of the populations. We're trying to get the populations to rebound. Right now, you do not want to eat shrimp. For every pound of shrimp that we actually catch, 4 pounds are bycatch, sharks, turtles, whatnot. So, but please check out Seafood Watch. Very informative. So our next question is Louise Murphy, or from Louise Murphy. Is there one of the 7 types of plastic that is worse for microplastic formation and toxicity than others?
That's a good question. That's something that the toxicologists have not agreed on yet. But it seems like polyethylene, it seems to be pretty bad, and polystyrene. We know that styrene itself is an extremely toxic neurodevelopment toxicant. It's regulated in drinking water. If you inhale it, it can cause brain damage. And so polystyrene is probably one of the worst ones out there for microplastics exposure.
Okay, our next question comes from Marguerite Herman. She's asking, what can third world countries like Cambodia do about the abundance of plastic bottle trash? Also, can we convince American, European tourists to use filters on the Cambodia tap water?
Yeah, this gets to a critical issue, which is places that don't have safe and affordable drinking water. What do? Drinking tap water in many cases is a lot worse than drinking bottled water and the environmental effects that could incur from that. So in places like Cambodia, I feel like it's unless you have a solution to clean up their water, telling them that they can't use bottled water is, it may not be humane. So there's definitely ways around this. I think, you know, getting to the root of the thing, going in and providing treatment technologies that are cheap and reliable and can be run by the people that live there is one of the solutions. Looking at the Philippines, they've actually banned plastic water bottles from being on ships. And so you can't, as a tourist, you cannot bring anything plastic on those ships. That's one way that they've gotten reduced their plastic waste input.
Okay, from Nick Phillips, have you seen any traces of cellulose acetate fibers in the water in your experience with microplastics?
Oh, great question. Yeah, definitely. We absolutely have. It typically occurs in low quantities in tap water samples, but we find it at much higher quantities in sediment. Cigarette butts are the #1 single-use plastic product that is found in the environment by far. And these particles obviously degrade. So we find it in beach sand a lot. That's where a lot of them ends up, as well as in ocean water.
The next question comes from Teresa Wright. Has consumer addiction to new furniture, cars, etc., contributed to this problem?
Yeah, I think, you know, getting to like the single-use lifestyle, transitioning from you know, the milkman that we used to have back in the day to just buying milk cartons. That's, you know, the idea of disposability is not just confined to a plastic product. Cars, in Japan, they replace their homes almost every 5 years for earthquakes. But, you know, the idea of rebuild and repair is, it's making a comeback right now as people realize that we can't just continue on with this disposable lifestyle.
And many of our kids are going and buying youth clothing, which is great. It's a hip thing to do, so I applaud them. The next question comes from your parents, Nancy and Jim Coffin. In your opinion, what is the solution to reduce the amount of plastic in our environment going forward?
So this needs to be an intersector, inter-collaborative decision. Like I mentioned with tap water, some people don't have safe water, so making a hard and fast rule is not going to be ethical. And so the way forward is really a holistic view, a circular plastic economy. And what this means is that the plastic producer, if they're producing something that's single use, or the producer of any product, needs to be responsible for the end of its life. Right now, California is putting in the final votes. They'll be voting for the final passage of SB 1422, AB 1080 this week. And this is the most progressive bill for single-use plastic control ever proposed in the United States. It requires that a manufacturer of a single-use item has to not only determine that the product can be recycled, but that it must be recycled, that it is being recycled. If there's no market for it, they have to buy it back and recycle it. Or they can make it compostable. This means typically in an industrial composter, not your home backyard compost, but at least it'll be biodegradable. So that's really one of probably the best solutions that's out there. But Europe is working on something quite similar that they call the circular plastic economy.
Well, I think that's it. There was another comment by Nick Phillips, no seafood or no seafood, K-N-O-W or N-O. So he's part of the Inland Ocean Coalition too. So hi, Nick. So any other questions? Well, Scott, that was amazing. I think everyone can, yeah, I think everyone agrees. That was very enlightening and we thoroughly enjoyed it. This has been recorded. So if you know anybody that would like to watch this down the road, please let me know. We'll probably, Scott and I will find out where we're gonna put this, but we'll put it somewhere and share it with everybody, so.
Thank you.
All
Thanks,
right.
everyone.
All right. Thank you, Scott. And everyone have a safe and great evening, and we'll see you next time. If you want more information about the Inland Ocean Coalition or the Wyoming chapter, please email me. I put it in the chat there for you. So
I'm sorry, I didn't want to jump in and interrupt it. Goodbye.
April?
But I did have a follow-up question. I'm sorry.
Yeah.
So I'm actually doing some research on nurdles here in North Texas, in the Dallas-Fort Worth area. Do you have how do nurdles affect like the waterways? Like if it's not in the ocean where the salt water can break it down and, make it into, nanoplastics or smaller, how does that affect inland communities and their waterways?
And Scott, if you don't mind, I might you might want to tell people what nurdles are.
Oh, sorry.
Yeah. Nurdles are pre-production plastic pellets. So this is the feedstock used by plastic manufacturers, and sometimes they illegally discharge them into waterways. As far as inland impacts go, those are not well characterized for nurdles. Typically, nurdles are pretty big, like you mentioned, April. You can see them with the naked eye. You can pick them up, and so you're not really worried about those ending up in your food or your tap water. They're almost certainly going to be removed from tap water, because you could see that thing floating around.
Yeah.
And so worms can interact with microplastics at that size, and it does affect bioturbation, which is one of the key things that worms do. There's actually been a couple studies looking at chickens that eat small plastic particles, like polystyrene particles, and they were found to accumulate them. They don't know if it's toxic to them or not, but typically most of the concern is on fish, right? If it ends up in the water, a particle of that size can be eaten by some fish, and while it might not be super toxic internally, it will prevent other food from it will prevent them from eating other food, because their stomach will be so full they won't be able to excrete the particles.
Thank you.
I think that wraps it up. So again, thank you, Scott, and everyone have a great evening. Thanks for the questions. Oh, we have another question.
We got one more. Do fires and smoke aid in the transport of microplastics in air transport? And how are you coping in California? That's a great question. I am almost certain that they probably make it worse if someone's home is burning. But if it's just the forest burning, I don't know if that would really make a difference. They found that in the microplastics and national park study, they found that there was more microplastics being transported by water, by rain, than air, but not a whole lot. And I'm actually really fortunate to be in Southern California right now, where the smoke is not nearly as bad as where it would be if I was at my home in Sacramento.
Scott,
so I'm hoping that.
Yeah. Did you see
go
the
ahead.
story? I think it was a research by out of UW, but it talked about if there is a heavier fire season, then it affects, I think it's flu or just respiratory, and of course we're all concerned about COVID now. So have you correlation, causation, have you read about that?
Yeah, I mean, air quality is one of the biggest public health nuisances worldwide. And the air quality during a wildfire can be some of the worst in the world. Last year in San Francisco Bay Area, during the major fires, or actually 2 years ago during the Camp Fire, the air quality was worse than in the highest air quality day in China. And so exposure to just a couple of those days, and you're going to see inflammation in the lungs, which is going to make you more susceptible to something like the cold.
So then what, we as just consumers just take notice of the high ozone alerts, that sort of thing, and take them seriously? Or there was some element, PB something, a study just recently, but it seems to be they were trying to look at it with regard to COVID, that sort of thing.
Yeah, so the ozone is actually a different thing. The ozone you get from smog, and you can feel it right away. It hurts to breathe, and so that is not going to have a huge impact on your long-term health. the particles. It's the really tiny particles that are going to cause long-term health impacts and that are going to make you more susceptible to things like COVID and other respiratory diseases.
But how do we know that as consumers? What marker or metric are we looking at? Does it
So
say?
you can check your, Cheyenne has an air quality monitoring facility just outside of town that they report to the EPA, and you can find that quite easily on the DEQ website. You can also just find it by Googling air quality Cheyenne. It'll show up right away. I look at the data for Cheyenne because I'm a nerd, even though I don't live there. And you guys have some of the cleanest air in the world, like actually in the whole world. So I wouldn't be concerned unless there's a fire outside. Then maybe stay inside.
Right. Okay. Thank you.
Okay, we're at the top
You're
of the hour, so we're gonna have to close this up. Again, thank you, and have a great evening, everybody.
Thanks,
Scott,
everyone.
stay on for a minute.
Okay.